Okay, this question is part one of a two parts question asking you to construct graphs for frequency and relative frequency. We have three kinds that we talked about: histogram, frequency polygon, and ogive. I will show you how to create those three, but here look at what they're asking you to use the frequencies for the distribution. Sometimes they ask you to use the frequency, and in part two we will do the same question but with the relative frequency. And so for now you don't need to know relative frequency, just watch part two and you will see that it's the same question. But the difference is that instead of asking about the frequencies and doing the graphs of the frequencies, you do the graphs for the relative frequencies. So first thing that we notice is we have the class boundaries here and the frequency of each class. The question is actually about the distribution of the miles that 20 runners ran during a given week. So for example, just to understand this question better, this number 5 means that 5 runners ran between 20.5 and 25.5 miles during a given week, and so on for the others. Of course, if you add up all the numbers in the frequency column, you'll get the total number of runners, which is 20. So just want to remind you of one thing, that for example, this 5.5 to 10.5 is the class boundary of which class? It would be the class boundary of the 6 to 10 class. This is because when we do class boundaries, what we do is we subtract half from this 6 and we add half to this 10. And this is where we get the 5.5 to 10.5. And so on for all of these classes. So let's just quickly do it. So this would mean this is from 11 to 15. And this would be from 16 to 20. And then this is 21 to 26. Sorry, I mean 25. And this one is 26 to 30. This one would be 31 to 35. And this one, the original class, I mean, like if you want, originally this was the class. And this would be 36 to 40. And so this is something that's not asked from you to do, but just to remind you, that's how you find class boundaries for classes. So let us start with the histogram. So this is the first one that we're asked to do. Then we'll do the frequency polygon, and then we do the ogive. So for a histogram, I will go to the next page to show you. So all what you need to do is on the x-axis, look here, you put the classes, the class boundaries, the data that you have. So if you see here, we start 5.5 to 10.5, so you draw it here from 5.5 to 10.5, then to 15.5, and all of the classes with the class boundaries showing. And then for each class, you look at its frequency, and that would be on the y-axis, the frequencies here. So for the class from 5.5 to 10.5, you will draw a rectangle of height 1. Then for the second class, you look at its frequency, it's 2, so you'll go up to 2. Then 3. So you see, this goes to 3, this goes to 2, and then to 5 all the way. So you will do this up to 5 for the class between. So let's change the color just for this class to emphasize one class at least. So this class is the 20.5 to 25.5, and the height is the frequency. So remember that the frequency is on the y-axis and the class boundaries are on the x-axis. And you complete this histogram. That's all what the histogram is about for frequency. So now we need to do the frequency polygon. This is also a simple task. So for the frequency polygon, all what you need to do is get the midpoints of the classes. So for example, let's see, how did we get this 18, for example? It's just from here. You find the average of these values, 15.5 plus 20.5 over 2, and you will get your 18. So it's the midpoint is just the average of the two limits of the class boundary. And find all of them, and then you see for the midpoint 8, the frequency becomes the frequency of the class that it's the midpoint of. And then on the graph you look, at 8 you put 1, because the frequency is 1. At 13 you will put 2. 18 you'll put 3. 23, the midpoint 23 of the class 20.5 to 25.5, it's 5. And so on. You continue doing these, and then you connect them to the x-axis and connect them with each other's. Let me do this with a different color, actually. So you do this. You connect them like this, all of them by lines. And actually, this is why this this frequency polygon, sometimes people call it line chart. Another way of getting this line chart is the midpoints. You notice that you can go back to your histogram and just take the midpoint of each of the rectangles here and then connect. So this midpoint here in each one, and you connect down to the x-axis like this. Okay, and this would be making the line chart, or as they call it for you, a frequency polygon. The last one, let's go back and see, they asked us to do is the ogive. The ogive is requires you to do the cumulative frequency. So this here is the ogive. Now from the frequency you can get what's called the cumulative frequency. And for the cumulative frequency, just notice one thing, is that we are changing from class boundaries to this. We say less than, less than, less than. So if you look at the first one, less than 5.5, look at our classes. There is nothing less than 5.5, because the frequency starts from 5.5 to 10.5, the frequency is 1. So you don't have any runners under 5.5 miles. So this is why for less than 5.5 you'll say the cumulative frequency is 0. And then less than 10.5, you notice that you have 1. And so you put the 1. And then for less than 15.5, it's both the 2 and the 1. So 2 plus 1, and that's why you're getting a 3 here. Okay, and so on. Another way to do it is, first one is always, if it's less than 5.5, you put 0. But after that, you just add the frequencies. You have first one, the 1 put it here, then 1 plus 2 is 3, 1 plus 2 plus 3 is 6, 1 plus 2 plus 3 plus 5 is 11, and so on. And of course, when you add up all of them, by the time that you finish, you will get 20. And those are the ones that are less than 40.5. Okay, 40.5 is the highest limit of the highest class. And so now you just look, if I could erase it, things would look much easier for you to see. So if you now look at the ogive, or some people actually, let me just emphasize this, it's important, that the ogive is sometimes called the cumulative frequency graph. Cumulative frequency graph. It's because the y-axis, look at the y-axis here, it has the cumulative frequencies on it. Of course, the x-axis always has the class boundaries, or the midpoints in case of the line chart. But it's for classes also. So all of the x-axis always has your data on it, and then the y-axis has frequency or cumulative frequency, and so on. So now you just put for each value, for less than 5.5 you have 0, so you'll put the 0 here. Then for less than 10.5 it's 1, so this is 1, and then 3. This value here, it's 3. Of course, you need to go to see that it's between 2 and 4. And then continue doing the rest of the dots according to the table that we have. And notice that the last one at 40.5, less than 40.5, we have 20. So we reach the maximum here. Or we reach the 20 runners. I mean, we reach our maximum of the number of people, because all of them ran less than 40.5 miles. And then you just connect, and this is called the ogive, or the cumulative frequency graph. And when you watch part 2, you will see that we will do the exact same thing that we did here for creating these 3 graphs. But instead of using frequencies, instead of frequency that you'll see here and here, you see frequency, and also here you see cumulative frequency, but instead of those 3, we will have the relative frequency and relative cumulative frequency, or cumulative relative frequency. You will see this in part 2. So please now go to part 2 and watch it, because you already have an idea of how things go with frequencies. So next you'll see what happens when we have relative frequencies, or we're asked to do the graphs for relative frequencies. So please go to part 2, and this part 1 will end here.